Hi everyone, this is Kirti from Suchi Systems. Good morning, good afternoon, good evening, wherever you're in the world. I gladly welcome you all for today's webinar, Non-Functional Testing in the Shift Left World. Before we begin, there are a few housekeeping announcements that I would like to cover. Be sure that your audio is connected properly. This is a live webinar and is being recorded. We'll be able to share the recording once the session is over. Also, please note that all attendees are in listen-only mode. If anytime during the webinar you have any questions, please feel free to type it in the Q&A box. We'll take it up at the end of the session. Moving on. The agenda for today's session will be the rise of shift-left testing, its types and some key requirements to making it happen, followed by testing non-functional requirements, the road travel, where we'll talk about how companies have been approaching non-functional requirements like performance, security, and usability over the years. And we'll conclude with non-functional testing in the shift-left world with some shift-left testing best practices. I'm very happy to introduce the speaker for today's webinar, Mr. Vasudevan Swaminathan. As President and Principal Consultant at Suchi, Vasu acts as a main contact between our team and our clients. He oversees and guides other lead consultant teams at Suchi at a very strategic level and also ensures that we deliver the project to the utmost satisfaction of our clients. Vasu also brings with him 2 decades of experience in testing, test automation, and managing large-sized teams for Fortune 500 brands. Apart from work, Vasu is an avid reader, movie buff, and an enthusiastic storyteller. We're looking forward to hear from you, Vasu. Over to you.
Hey, thank you, Kirti. Thank you so much. And welcome all the attendees to this webinar on non-functional testing in the shift-left world. This has been a topic that I've been wanting to talk about for a while. Personally, having been in the testing space for about 20 years now, I've seen the evolution of non-functional testing since the 2000s, actually. So with all the Agile and DevOps moment happening and everything, I always wanted to talk about this topic, and hence this webinar today. As Kirti said, the idea is to talk a little bit about understanding shift left and getting into details of what this is all about and things like that. I will start off with a slide that is very commonly seen or known to many of us, actually. Usually we talk about the cost of fixing defects, and when we talk about the cost of fixing defects, we talk about how costly it is to fix a defect when it is found later in the cycle. It's a common thing. We have been talking about it since the late 90s, actually. But in this particular context, I wanted to talk about basically shift left and address where this cost of thing is coming from. Cost of fixing defects is coming from, basically. So if you look at it, shift left per se, means that you are shifting testing to the early part of the software development life cycle. In Agile and DevOps terminology, we call it as test early and test often, right? So basically the idea is to, make sure that earlier when a lot of testing activities occurred late in the cycle, it takes longer to figure out problems and the cost is more to fix them, basically. So when you try and do it a little early, it is not that you're going to solve all the problems, but it is more of a prevention mechanism. That's why, shift left is not going to be a silver bullet to all your problems, but instead of doing complete shift right or doing testing later in the cycle, you're trying to see if you can do a few things early in order to get a sense of where things are going, what kind of problems you foresee and things like that. That's the whole idea behind doing shift left, basically. Particularly when you wait to perform testing practices later in the development cycle, your non-functional business requirements in particular, such as security and performance testing, are kind of fundamentally built in or ingrained in your code that all you can really do is patch them up rather than fix them properly. So shifting left is all about doing this identification and prevention of defects. That is why you go into shift left, actually. So if you look at the first image that you see in this presentation, we are talking about, where, defects get introduced. As we all know, and as we all can see, 85% of the defects get introduced as part of the coding cycle. Whereas when you look at unit testing or functional testing or system testing, you don't see a lot of things getting introduced. We see a slight increase during the system testing phase, but that is negligible. So 85% of the defects we see are introduced during the coding phase, basically, right? So why this happens, we can talk about different things, whether the developer makes mistakes or misunderstands the requirements, or they don't think through the ramifications of a particular code or piece of code, whatever it could be. But developers introduce defects as the code is being produced, actually. So defects are also introduced in the application when it's time to put the pieces together, especially when multiple teams are involved, and especially in modern architecture, like let's say microservices and more complex things. It is easier when teams come together and start building things, and it is very natural that as we start building the code as a team, it is very natural for defects to also get introduced. Now, when you look at the second image on the right hand side, you can see that we already know this. Unlike finding, most of the defects ideally should have been found in coding phase, which is not the case, basically. So if you look at the second image, the percentage of defects found actually gets moved. It gets shifted towards unit testing, functional testing, system testing, release, and things like that. This is also not very surprising, because typically you find bugs when you start testing, and it can be difficult without a proper infrastructure to begin testing before everything is ready. Because when you are coding, you don't have any infrastructure ready. You don't have your environment ready and things like that. So naturally, only after a certain phase, you have things ready. And that is when you start testing. So you start finding defects later in the cycle. But what we also see here in this image on the right side, the second image on the right side, is that while bugs are mostly introduced during coding, they are almost never found at that phase. So absolutely nothing is found in that phase. Everything is found only later, actually. So fixing this becomes even more difficult. And that's what the third image says. What is the cost of fixing them? For example, numbers can vary. Different people could have different things. But personally, I think, I have personally had the chance to look at fixing regression defects and things like that, which has been pretty expensive. When I say expensive, you cannot put a dollar value to it, but the number of people who come together to find where the bug was found, which test case got failed, and the number of people it takes from a development standpoint to fix it, all of this is what this number is all about, actually. So coding phase, if you find it, it could be a 1x. In unit test, it is 4x, 10x, 40x. And when it gets to release, it is 640 times, basically. The numbers can be, debatable, but there is no question that there is a number involved there, right? And at this phase, it really starts to kind of get interesting, because you see a progression of cost that is kind of bad, and that dramatically increases when the defect is found in later stages, basically. So letting a bug sneak through to system testing is 40 times the cost of finding it during coding, or 10 times more costly than finding that same bug during unit testing, right? And there is a reason for this cost escalation also. As I said earlier, the time and effort it takes to track down the problem, the challenge of reproducing the defects on a developer's desktop as independent systems, like, let's say databases or third-party APIs are brought in. And it's very difficult to, say that, it did not happen at the developer's end, but it was more to do with the infrastructure and things like that. And what is the impact of the change that is needed to fix a defect? If it's a simple bug, it doesn't matter so much. But if you have it in many places, you have used the wrong framework, or you have built code that is not scalable enough for the expected load, or that it cannot be secured, it's a larger problem, right? Security, performance, and things like that. These are some of the reasons why you shift left, actually. These are some of the reasons why you are shifting left. So the last image that you see in this slide talks about a bulgy orange curve and a left movement, a blue color arrow that you can see. I've referred this from Capers-Jones as part of the Applied Software Measurement and Global Analysis of Productivity and Quality, where this is a very nice representation of 4 images showing why a shift left movement is even needed in the last image, basically. So if you look at the orange line on the graph that you see in the last image, it kind of illustrates a proposed defect detection cycle that is based on earlier testing. So you are doing shift left, which is testing early. So it kind of shows a cycle there. You can see the orange detection curve growing larger on the cheap side of things and smaller on the expensive side, giving us a pretty significant cost reduction. This is why you move towards shift left, basically. So how do you do this? Basically, this shift left relies on a more mature development practice, such as, sometimes we talk about software testing pyramid. For example, people talk about top down versus bottom up. In a software testing pyramid, an ideal software testing pyramid, we are talking about developers creating a set of unit tests that cover the code reasonably well, and functional testers and API testers do as much as they can and minimize reliance on late cycle testing. So you have just enough manual and UA tests to prove that everything is working actually. This way, the late cycle tests are there to prove functionality, not to find bugs. This is a very important point to take actually. When you do testing towards the shift right, basically, as I said earlier, you are not going to ignore shift right. But when you try and do shift right testing, those late cycle tests are there to prove functionality, not to find bugs. So that is why if we have a shift left approach, there is a defect detection cycle that happens, trying to find more defects during the unit test, functional test, and other phases, basically, instead of trying to move towards other areas or trying to start finding defects in the later phases, basically. So the idea is to make sure that when you run shift right tests, the idea is to make sure that you are basically ensuring that functionality is working fine. But the idea is not to find bugs. So test early, test often is the mantra of teams that are doing shift left testing practice. Now, some organizations stop at this point, right? For example, you may not do anything more, but as you do more and more shift right, based on what inputs and information that you receive from shift left, then you can strategize your tests in such a way that your shift right test can be even more valuable, and it can be more precise and things like that, rather than trying to find issues at that stage, basically. So it is very important that, we understand these 4 images. Now, as far as applying the shift left approach goes, how do you shift left, right? How do you basically shift left? Because you're already running something and all that. You don't start something from day one. So for the sake of brevity, let's say the shift left testing approach breaks down into 2 main activities, which is applying development and testing best practices. It is, though we talk about shift left testing, the idea is to make sure that there are development best practices and testing best practices. And there are some areas such as continuous testing, doing more of automation and things like that, which is exactly some of the best practices that we will talk about as part of this presentation later in terms of applying the shift left approach. So when we talk about all this, we will get to know more about what is static code analysis, unit testing, and things like that. But these 4 images basically can help us to understand more in terms of how the overall shift left testing part helps in the betterment of quality and prevention of defects, basically. So this is probably a good introduction to what shift left is all about. Let's move on from here. Now, talking about shift left testing, there are a number of articles in terms of how shift left testing helps actually. So, for example, there is a very nice article in Carnegie Mellon University's Software Engineering Institute website, where Donald Firesmith talks about 4 types of shift left testing, which I have tried to summarize here basically. So there is a traditional shift left testing, then there is an incremental shift left testing, then there is the agile DevOps thing that we are doing right now, and slightly overlapping with the model-based shift left testing. I will try and capture a quick snapshot of what these 4 types are. But as I said earlier, go and visit Carnegie Mellon University's SEI website, where you will see a very nice explanation with some eye-catching images as to how the types of shift left testing has emerged, basically, different types has emerged. Now, it is important to talk about the V model here before we talk about the types of shift left testing. When we talk about the V model, in a general V model that was prevalent a few years or many years before, around, let's say, the 2005, 2010 timeframe, if you look at the V model, on the left side of the V model, you always look at requirements, design, development, systems testing, requirements, design, development, and then, low-level design, high-level design, and things like that. On the right side of the V model, you look at unit testing, integration testing, system testing, acceptance testing, and things like that, actually. That's how typically the V model looks like. When we talk about shift left, we have to be very conscious and careful about the terminology here. The original shift left that we are talking about is moving towards the left within the V model itself, basically. Can we do testing early in that V cycle or V model is what the shift left part is all about, actually. So when you talk about that, the first type that has emerged is traditional shift left testing. And when we talk about traditional shift left testing, it moves testing lower and slightly left of the classic V model, as I said earlier. So if you focus more on, let's say, unit testing in the beginning and try and build test cases from there, it's the traditional shift left testing, which many companies have started doing, actually. And then there is an incremental shift left testing, which is you do releases in boxes, and then it comes in increments, and then you start doing incremental testing on each of the incremental boxes that come out, basically. And that is one way of doing shift left testing. In each of these boxes that I get for release or that I get for testing, how do I basically plan incremental testing in that? That's the second type. This is also something that has happened. But where we are talking about shift left testing to a major part today is more in terms of the third category, which is the Agile/DevOps shift left testing. The reason we are focusing on that is the V model has come under significant criticism today, right? When we talk about V model, we say from waterfall, we have come into V model, and then we have looked at other models, actually. And finally, we have settled for Agile during the last 10 years at least, right? So what is the significant criticism that is placed on the V model? People basically say that it is more of a sequential waterfall, basically. Instead of a typical waterfall, it becomes more like a sequential waterfall. And, in a V model, release to market, getting early feedback and all that is challenging. And that's the reason why people moved into Agile and, a DevOps model, basically, where you can do a release quicker to market, get feedback early, and then plan your other things, basically. So the objective is the reason behind doing test early and test often is to make sure that you are able to take the feature to the market quickly, get some feedback, see how things come back in terms of feedback, and then try and address any concerns or any comments and feedback that you receive, basically. So in that context, if you look at it, that is where most of our focus is today. 1 and 2, to a large extent, people have done, but 3 is where most of the focus is today. And when it comes to Agile, DevOps, and shift left testing, there is something very critical that we need to understand. And that critical thing is particularly shifting left in the Agile DevOps world is all about 2 key DevOps practices. One is continuous testing, the other is continuous deployment. Now, when we talk about continuous testing, it involves automating tests and running those tests as early and often as possible, along with things like service virtualization to mimic unavailable systems, because that is something that we will talk about in the shift left world. We said earlier that shift right testing happened because systems were not ready. So what do we do, or how do we do it in shift left today? We will talk about that, actually. When dependent systems are there, when we do not have a system ready, we have done it using mocks before. If you remember the old age of testing, people talk about mocks. They create stubs and things like that. So stub is more like a mock that you will bring in as a absence of functionality, as a replacement for an absence of functionality, right? So in this case also, when we talk about continuous testing, it is about automating more tests early in the cycle, and then use mechanisms like service virtualization to mimic unavailable systems. As far as continuous deployment goes, we are talking about automating the provisioning and deployment of new builds, enabling continuous testing to happen quickly and efficiently. Because when you automate more tests, but if you do not have an environment to run them, what do? There is not much of use, right? So when you talk about continuous testing, you also need to take into consideration continuous deployment, which is provisioning the infrastructure, the missions, and everything, basically. So as far as number 3 goes, it is important that you have continuous testing in place. Number 4, model-based shift left testing is more in terms of, can I avoid a defect even before it comes in? Ideal world, very well thought of, but it is not that easy, as we all know. Like I read in an article where someone said, if you go to a dentist asking him to shine your teeth, if you go for a teeth cleansing or teeth cleaning exercise, how would you define the goal for teeth cleaning, right? If your teeth is white and you say that I want it more whiter, how much white can you make it, right? That's precisely what model-based testing ends up with. I can find defects, I can do a few things, but if you say, even before I start off requirements, if I should be able to capture these things, to a large extent you can try, but there will always be a challenge there actually. So I think the third option is ideal. So getting into the fourth type of shift left testing is still a challenge actually, but I think there is some overlap happening today by spending more time on looking at user personas as part of usability testing in the design phase or requirement phase, or looking at what kind of security challenges will this application undergo by thinking about it in the requirement stage itself. All these are some of the steps towards model-based shift left testing. But for the most part, we'll be discussing three and, for the most part, we'll be discussing three today in the context of shift left testing. But we will also look at some of the overlapping areas in terms of how model-based can actually happen, particularly taking the context of non-functional requirements in the shift left testing world. But broadly, to wrap up this slide, these are the four different types of shift left testing that has evolved in a sequential manner. So first, traditional shift left happened, then incremental shift left. What is happening now is Agile DevOps, and to an extent model-based, and the future could be model-based itself, where people try and capture things even before they start writing tests and things like that. An ideal world to go. But this is a sequential way of building things in the shift left testing world. And as I said earlier, you will be able to find an article by Donald Firesmith in the Carnegie Mellon website, Carnegie Mellon University's Software Engineering Institute website, actually. With that being said, let's move forward. Thank you. So talking about non-functional requirements, what are non-functional requirements? We all know that whether it comes to usability, performance, capacity, load testing, security, all these are different types of non-functional requirements. I mean, we can take n number, including accessibility and things like that. But for the sake of this discussion, I'm restricting it to three areas: usability, security, and performance, which are the three areas that we generally come across as challenges in the process of non-functional testing. Again, there could be accessibility and capacity planning, hardware planning, and a lot of other things actually. But some of them are more allied areas to this itself actually. But predominantly, the challenge that comes in today is what happens when the website crashes. What happens when a Black Holiday or a Black Friday happens or a Cyber Monday happens? What if my website crashes? How do you predict all these things basically? So most of our non-functional requirements today comes down to these areas. So let's talk about usability, security, and performance. Now, from the 90s or late 90s to 2000s or mid 2000s, the focus itself on usability, security, and performance was very minimal, as we know. For example, usability is a term that has recently become in the last 5-6 years, has become very famous. User experience has become very popular. But terms like usability were not used very frequently in the 90s, basically. There was very limited focus on usability. Similarly, security, there was no formal security testing in place. Even today, a lot of companies do not have a formal security approach or strategy in place. Only after they find a problem, they get into it. So security still continues to be a challenge, but it's better than what it used to be in the 90s. And when it comes to performance, most of the times what would have happened is performance issues would have been caught in production first, and then they would have thought about it, or that would have probably led them to a self-realization stage where they would have said, hey, we did not expect this to happen in production. How come 100 users suddenly came in? I didn't expect this, because no one would have thought that the website was even prepared to handle 100 users at that point of time and things like that. So appearances of the first commercial performance testing tools started only after production defects started coming in. Like, for example, Load Runner, which is one of the oldest tools that I know of, came in, around the late 90s, early 2000s, but it was not very helpful at that point of time to do a complete performance testing and things like that. So the more and more issues came up, the more and more tools have come actually, if you look at it. Today, if you look at Parasoft SOA test, or let's say Postman, or any kind of tool for that matter, load test, Parasoft's load test, or anything for that matter, all that has come in mainly because these issues have started coming during the last 15 years actually, and that has introduced to a large extent the tool vendor market basically. Similarly, in the 2000s, if you look at it, we have started with a few things in terms of usability. What if this breaks down? What if the user is going to do this? In fact, if you remember, when we write test cases, people have always said, can you think and write test cases from a user standpoint? And that, in fact, has led to agile spin-off practices like behavior-driven testing or, models like that. Because today, a lot of companies are going into behavior-driven models, saying that I want to write a test case, or I want to write a scenario or a use case itself as how a user would basically approach it. So given that a user is trying to log on to a retail website, when he goes to the apparel section and he chooses to do something, when he tries to do a checkout, then this should be the output. So given then when all these keywords have come as part of behavior-driven development, and feature files are being written, testers are using more of domain-specific language today to write test cases, which are being automated the next day and things like that, right? I mean, next day is just for reference. It could be immediately even automated, right? Because the idea is to have a DSL or a domain-specific language that would be easy for everybody to understand, rather than testers writing very esoteric test cases that might be difficult for the rest of the community. When I say community, rest of the stakeholders to understand, basically. So if you look at the 2000s, that's when usability started. Security, there have been tools like OWASP and open source tools and all that have come in to do security testing in terms of penetration, vulnerability, and everything. Same with performance. A lot of times, performance tools people have started using performance tools and things like that. So this is the scenario that used to be between 1990s or late 90s to 2010, 2012 actually. So until the time when people started actually talking about the shift left movement. So when they started talking about the shift left movement, what have they done to the non-functional requirements? How are they addressing non-functional requirements today in the shift left world? Let's talk about that a little bit. Now, this is something that we spoke about earlier. Shifting left non-functional tests without proper deployments was difficult. That is why we spoke about continuous deployment and continuous testing as two practices that are very, very important for shift left testing. So without deployments or without a proper environment, you cannot do non-functional tests, in the shift left movement, basically. So when we talk about a performance or a security or a usability today, what are we doing basically? Now, there are a few things that people are doing today, right? For example, I have seen personally that people have started using tools like Postman or integrate tools like SoapUI with Selenium to run a few tests within the early part of the design itself, right? For example, we have seen that happening. You can take examples of Selenium, which is being used more in terms of functional tests, but people have also started using, functional test tools like Selenium to integrate with Parasoft and things like that. And then they have started writing tests actually. So for example, how do you do this? Let's take an example of, benchmarking for performance. Let's say I need to check for 50 users or 100 users, basically. Now, you can actually, what people are trying to do, or what many organizations are trying to do today is, if you insert Selenium functional tests in the continuous integration, continuous deployment software pipeline, and then automate them with a tool or a companion tool, I should say, like a Postman or a SoapUI to monitor execution times with each build, then you can capture a pretty good benchmark for any application component or service, right? This could be an API, this could be a REST call, this could be anything for that matter, right? So if you find some kind of a deviation in response time for whatever reason, the build can notify the build platform or developer that some exception, mostly non-functional, caused a particular component to slow down. This is what you can do in the shift left world today, actually. So you can insert functional tests for benchmarking, but typically when you try and do or when you try and insert functional tests for benchmarking, it might actually come back and show you a slowdown in some part of the system. It could be an API response, or it could be anything else actually. But that would basically mean that you are getting some kind of non-functional issue as a pattern basically. And that basically points to what kind of component is causing this failure and why is this actually happening. That is one way, which is inserting functional tests to do benchmarking, which is more on the performance world. Same within the performance world, if you take load testing, can we reuse tests and repeat under load? For example, in Shift, typically what people do is they use a tool like Load Runner, as I said earlier, which require almost, if you want to try for a web page, you have to finish that UI completely for the web page. You have to completely finish it, and then you have to put it inside Load Runner to see, can I invoke, a set of users to see how this page is performing and things like that. Instead, what is happening in the load testing world within the shift left context, people are taking Selenium tests and they are doing, some level of load testing using that. Again, I can take the name of, let's say JMeter, or I would take the name of, let's say, a load UI or something like that from Parasoft, which people are using today. If you have to take open source, the good example is JMeter basically. So people are combining Selenium with JMeter tests, and then they are trying to infuse some level of load actually, and trying to see how the page behaves under a load. So beneath the scenes, if there is an API or any kind of mechanism that is actually making the page to respond back, you would be able to try this load early in the cycle in the shift left model by trying and doing this and getting a sense of where this is going basically. And that basically helps you to design better tests as you move towards the shift right world actually. So this is one example. Similarly, what you can do, as I said, if you want to try, let's say, for some basic security checks and service and integration or something like that with respect to security, you can always try and do them in the same format that I mentioned, right? You can take some Selenium test, integrate it with JMeter. You can try and mock some different users based on access privilege, and then try and see, if you can run some security checks and try and see how it is basically behaving and things like that. So this is a classic example of an early stage load or a performance test that is actually shifted left, right? And from there, you can combine different combinations of web style, UI calls, non-UI calls to APIs, or you can build event queues for a hybrid performance test that can exercise multiple layers of the application's target ecosystem without waiting for actually a finished application, right? All this is something you can do within the scheme of, within the realm of security, performance, load, and things like that. Number 3, we spoke about environment, right? We said shift right happened mainly because environment cannot be ready when you're talking about requirements. So what do you do in a shift left world? The last hurdle to shifting non-functional testing to the left is the environment, right? Where the applications actually live. So today, if you take a modern application function or modern application that you use, the world is full of data and service dependencies. Things have changed a lot. It is no more a 2-tier, 3-tier and things like that. The world is today full of data and service dependencies. You have to pass data back and forth, and you have to look at the dependent systems and things like that, make sure they are all working together and fulfilling each other's request, response and everything, right? So this is where environment-based testing with a tool like service virtualization solution makes sense actually, right? So you try to mimic all of your upstream and downstream dependencies around the live app, right? The app is not fully ready, but you are trying to use a model like service virtualization to make sure that you are able to mock or you are able to virtually create the service dependencies that you have across all your upstream and downstream systems. This allows you to simulate things like a partner's, let's say, for example, in banking, you can actually simulate a banking partner's ecosystem, or let's say you want to make a call to an open banking API from a particular bank. You can actually simulate this, right? So, or let's say an air traffic system, or let's say an e-commerce system that is talking to a third party for payment, anything it could be actually. Ideally, the things that we are talking about here will never be in your control, correct? They are never going to be in your control, or they are not going to be available in your dev test lab. But today, in the shift left world, with automation being done early in the cycle, with continuous deployment helping in provisioning, And with mechanisms like service virtualization, you will be able to create the full life system, though it is not actually available, but do a sense of all these tests by mimicking systems, passing data, looking at service dependencies and everything. And all this basically gives you an idea of what are the potential areas where I might be able to find defects, or what are the areas where defects can actually crop in or come from. So that is why we said earlier that this is more in terms of a defect prevention exercise more than a defect detection exercise. So shift left helps you in defect prevention. As they say, prevention is better than cure. So you don't want to basically look at getting into shift right and trying to see where my issue is, but doing these tests that we just mentioned using the shift left model can help us give indications in terms of from where these issues are coming from. And how is it going to help us? We get inputs that can help a tester or a developer code accordingly or write test cases accordingly. And that way, we will be able to make sure that the functionality has been covered well and non-functional areas have been to an extent tested well, though there could be one or two issues that might come in during UAT testing or production, which could always be a real-time scenario. And you cannot, as I said earlier, taking the dentist example, you cannot have 100% white teeth. It's a very relative topic, right? So it's difficult to say that. But you can claim that you have 90% white teeth and you do not have any blemishes or black marks or anything in your teeth, basically. That confidence you can get by doing this shift left approach. And that is what we are talking about here. So dependencies can be listened to and they can be captured as virtual services using service virtualization, components that can respond better than the real thing, actually. So, when you do this dependency, components can actually respond better, and you will be able to make notes of which component is failing, what kind of issues are coming in, and things like that. Based on that, you can plan things with your developers, testers, and others, including, writing test cases that are more oriented towards the defects that you identify during the shift left testing phase, instead of telling a tester that can you go ahead and write test cases for this feature. If you have done this shift left approach on performance or security or load testing and things like that, then you can actually tell your tester that, hey, you know what, in shift left we found this. Is there a way we can do better test cases as we move towards integration? I think that part is the challenge, actually. Can we look at more better test cases as we move into system testing or acceptance testing and things like that? And that is how your software testing pyramid can be built. And that's what we spoke about earlier. So personally, I think I can share an example of one of our clients where we automated functional tests, using Selenium and JMeter to get a benchmark for a loan application component. Okay, then we kind of reran the tests with other tests for data queries, API calls, and everything to a virtual service mock of a third-party credit service. So as you know, in a banking or a financial institution, what happens is there are a number of systems that come in. You can have a fraud detection system. You can have a alert mechanism. You can have a core banking application sitting inside. You can have an open banking API. You can have any number of third parties doing something for you, actually. So if you have to mock all of this, you cannot wait for your application to be fully ready to do everything, actually. And that is why it is important for us to look at these systems and try and create mocks and everything. We had a similar application like that. I would say a Swiggy kind of an application. Okay, so the customer wanted to go live in 90 days to the market. Think about the number of parameters and integration services and dependencies that is involved in creating a service like Swiggy, right? When you order food in Swiggy, for that matter, you only know that the food is coming and it is coming to you and all that. Think about the number of systems you have in the service behind the core service, I'm saying. So you have to integrate with a travel partner. You have to integrate with somebody like Zomato. You have to integrate with somebody like a person who will be providing you with tracking the user. You'll have to check for somebody's time. And then there is also a routing mechanism. For example, I am in Thorepakam, for example, let's say, and another guy has ordered food from Perungudi. It becomes easier for them to combine both the things without having two people go to it, especially in a pandemic or a pandemic world today where they're trying to optimize costs at all levels, right? So who will provide this routing mechanism, things like that? So when we tried developing an application like that, we had to mock all of these things in the first 4 to 5 weeks itself, because in 12 weeks you're going towards a release. You cannot wait until the 12th week and say, oh, I missed this. So we started looking at all of this from a requirement standpoint, looked at all the challenges that we had, started writing the dependencies, started looking at load tests and everything, basically. So all this gave an idea to us in terms of what could be a challenge. In fact, in the banking application that I spoke about, there was a virtual API service which responded too slowly. So, then we thought, if this service is responding slowly, what would happen to the component that is going to be under test? And, we started simulating different things actually. So we started kind of putting together race conditions that emerged that caused the transaction to fail, when the response was too fast and things like that actually. So for example, I'm waiting for something. I'm waiting for a certain time, but the response came too fast actually. So because it was not expecting the response to come that fast, it couldn't handle it actually. So these are multiple scenarios that can happen to any kind of testing application. So all of this we try to take into consideration and then try to take scenarios and things like that basically. So that's something I just wanted to highlight as part of, usability, security, performance and other things. But hope that gives an idea of how non-functional testing, how baby steps towards non-functional testing can be taken in the shift left world. Let's move ahead. This is more of a, can we do this, or a best practice, as you can call it, or, more in terms of what is that I can do in each of these phases in terms of non-functional testing in the shift left world. Right. So when we talk about, we are not talking about a specific model like Agile or anything here. We are talking about the software development lifecycle in general, right from requirement to design to development, testing and release. What and all I can do in each of these phases in terms of a sequence, right? So when it comes to performance testing, what is that I can do from a requirement standpoint? What is that I can do in development? What is that I can do in testing? And what is that I can do in release? Similarly, when we talk about usability, what can I do in requirement? What can I do in design? What can I do in development? What can I do in UI usability testing? What can I do in testing? And what can I do in release? And when it comes to security, similarly, how do I start with a shift left in terms of requirements? What can I do in design? What can I do in development? What can I do in testing? And what can I do in release? So this is a very, a coming together of all that we just spoke about, right? So this is a good mix of shift left as well as shift right, and also the interim pieces that lie there. For example, when you take performance for that matter, we are talking about user-based assessment. So in requirement phase, what can I do? I can discuss and say, hey, I expect this application to scale up to 500 users. And I expect these challenges as far as the user base goes. When these kind of brainstorming sessions happen, you start taking notes in terms of what are the possible things I can do with respect to looking at this application from a development standpoint. Now, when you talk about performance, you can see that the design phase is empty actually. So there is nothing much you can do in the design phase. But if you have done a user-based assessment in the requirement phase, then you are starting to do profiling, performance, smoke testing, and those kind of things in your development. And when we talk about development, I'm not, don't imagine a typical team of development that is looking at it. I'm talking about an integrated model where testers and developers discuss and say, what are the things that we can do here? Similarly, at that stage, you might want to look at static code analysis. You might want to run a few tests here and there and see how that is working actually. When we talk about development, there is also a portion of test there. We are not talking about pure development here. I'm talking about the use of tools like, let's say, PMD or Corbatura for static code analysis, and using that within the development phase to automate tests actually. This is a challenge today, right? For example, if you go and tell a developer, why are you writing limited unit testing today? He will say, I don't have the bandwidth. I don't have the ability to cover this. So which means that developer needs to be supplied, or he needs to be supported with automated tests. And these are not the automated tests that we are looking at testers to come and write. We are talking about developers writing static code analysis or developers writing automated tests for the code that they are going to build. And that's what test-driven development is all about and things like that, right? So at this stage, can they do some profiling? Can they write some automated tests for performance? Can they do some smoke testing as part of automated tests? Because if you ask them to do all this manually, it will be very difficult for them to do it. And once assuming that they are doing some of these automated tests in development, then the testing team or the testing phase itself can focus on performance, actual load testing, building performance dashboards, aggregating all the performance results and everything actually. And when it goes to release, it's more of a shift right approach where you are actually assessing, monitoring things, looking at where things can break, looking at an actual user scenario and things like that. So the rightmost side is more of shift right, while the leftmost or the first two phases are more shift left actually, right? Same with usability. You can do a user persona search, look at who is going to use this application. It could be let's say the application is a e-learning application. It could be a teacher. It could be a student. It could be somebody else who's a different stakeholder. Do we know who else is going to use this? Will there be a substitute teacher who will be using it? What if the actual teacher goes on leave and suddenly a substitute teacher has to come in? How will they be able to take it from here? Does the application provide any kind of support to them? These are multiple things that you can look at from an e-learning perspective. So user persona research from a usability standpoint, then you can start doing UI UX review during the design phase. Now, you may not be able to add tests for usability in development, but you can do a lot of work in terms of UI usability testing as part of the testing phase actually. And then do a shift right in terms of usability assessment. Similarly, with security testing, you can look at risk assessment, you can look at threat modeling and security design review, all as part of the shift left approach. And then you can write static code or static app security testing, which is, I'm talking about developers. When you say testing, don't think it is a testing job there. What you see in the development phases, we are talking about automating tests. And that is where continuous automation and continuous deployment is going to play a very critical role. So developers can come in and write static app security testing, or they can write some security tests as part of static application code and things like that. Then testing will be able to take it further by making sure that they are doing more dynamic app security testing and things like that. And naturally, as part of DevOps, you can always set up a DevSecOps moment to make sure that all of your operations, security, development, and everything is coming together, basically. If you actually look at it, this is a sequence. You are building the testing pyramid here, actually. So at the bottom, it could be a unit test that is happening at the development end. And then on top of it, you can actually build that testing and release versions, basically. So this is more in terms of an idea of how non-functional testing happens in the shift left world. Let's move ahead. As we come to the end of this session, we wanted to talk about a few best practices from a shift left testing standpoint. The first thing when it comes to shift left testing is you have to look at automate. Write tests for your functionality you create or performance you intend to improve. This is for the developers, okay? Static code analysis, again for developer. Check code for programming errors, violation of coding standards, security issues, etc. Then we're talking about unit testing. So this is a very important area. Your developer can burn out sometimes. That's what I said some time back, right? If your developer is writing fewer unit tests, it's a sign of concern that can be attributed to, orchestration of tests or long integration tests in the name of unit tests, etc. This is very important. If you are a QA manager or a development manager who is attending this session, it is very important to make a note of this, which is, why is your developer writing limited unit tests? And the answer always comes in is, I don't have bandwidth. Why is he not having bandwidth? Because we are not doing automate first, and we are not doing static code analysis. Because if we set those two processes, he will get more time. Now, if you are doing that and he says, I'm still having a problem, it means that either the tests are not orchestrated in a pipeline well, and secondly, they are actually writing long integration tests in the name of unit tests, which we need to check and see how we can release them from that effort actually. Unit test needs to be only at a certain level. It cannot get too bigger actually. And that is another important best practice. Number 4, always focus on testability. This is more for the testing team. This is more for, in today's world, there is no clear distinction. Today, it's more of full stack developers, full stack testers, and everybody actually. So all of them need to come together and do. But when we talk about testability, when we talk about focusing on testability, we are looking at how can I look at things from a user standpoint? how can I introduce continuous testing in a manner where, most of my tests can be, run once the build gets, once the build gets out and things like that. And finally, is there a challenge waiting for dependent systems? How do we address that? Can we simulate unavailable systems to start testing sooner? Now, this need not be a very expensive tool like a Parasoft Virtualize or any other big tools actually. A simple Mockito or JMock kind of tools can actually help you to do certain level of virtualization. So the term service virtualization need not, overwhelm you or bother you basically. We are talking about starting off with some basic stuff in terms of mocking the environment, making sure that we are checking the dependent systems through mocking tools or service virtualization tools, if those systems are not built today, if they are absent, and if they are going to come in only in the future. But all of this requires extreme levels of collaboration also in terms of making things happen. So these are some of the best practices from a shift-left testing standpoint. And with that being said, I would like to wrap up this session on non-functional testing in the shift-left world. I hope this session was useful, and there were some takeaways from this session. So we will reserve the next few minutes for some question and answers from the attendees, and I will try and answer them to the best extent possible. Thank you. Kirti, are there any questions that you have? I mean, are there any questions that you see? Because I don't see anything yet.
There isn't any so far, Vasu.
Okay, there was one from Manigandan Kannan. Okay, it's more of a comment. Thanks for sharing the knowledge on shift-left testing. Oh, thanks, Manigandan. Thanks for taking the time to attend this, and I hope it was helpful. Thank you. Any other questions? Anything on non-functional testing, setting it up in the shift-left world? The right combination of shift left versus shift right. I think I addressed most of it. Shift right needs to be more in terms of ensuring or proving that the functionality is working. Shift right approach is not to find bugs actually, but to make sure that nothing is breaking and everything is working fine, because we should have done most of it could be in the testing phase. Definitely, Manikandan again has asked if you can share any links to understand more about this. Definitely, we will try and please share your email with Kirti. We can share some links with you. We'll do that.
Also, there is a question. Can you please explain on fault tolerance from Daniel Xavier?
Fault tolerance. I think I answered this in the website, I mean, in our blog, actually. See, I think Daniel was the one who had mentioned saying that, is it business continuity planning? Sort of, actually. It is, in a way, business continuity planning. But when we talk about business continuity planning in general, it becomes more in terms of management stuff. So when we talk about fault tolerance, it is more at an engineer level, basically. So though the terms can be giving a similar meaning, business continuity planning is more in terms of ensuring that business is not hit. That is not fault tolerance is all about. Fault tolerance is more in terms of when you design an application, how do you make sure if when something goes wrong, I'm able to still rely on some kind of a backup model to run the system without the application getting crashed. To give an example, I can say this. If you have watched this movie called Sully by Tom Hanks, it was based on a real incident. So United Airways flight number 93 took off from New York's LaGuardia, I think, and it was on its way to Boston, I guess, actually. So if you'd have watched the movie, the flight took off. I mean, this is a real incident, though I refer to the movie. This is a real incident. So the flight took off, and I think in 2009, I think. So the flight took off, and the moment it hit the airspace or it hit the air, birds actually crashed the flight engine. And both the engines failed. Now, look at this from a fault tolerance standpoint, right? When both the engines fail, what should happen? The flight should crash then and there. It should fall down right away, correct? If the system was designed that way. But what happens? It gave time. Though both the engines failed, which is very, very critical, there was some time, because the model was the engine or the machine was not designed to fail immediately, even though the engine had failed. It gave some time. There was some level of fault tolerance built in the aircraft to decide for the pilot, to make some decision for the pilot, basically. So it is very, very important to understand this from that standpoint. So Sully, who was the captain of that flight, had some time. He can decide whether he should land in Teterboro. Teterboro is another airport near LaGuardia. So he had a chance to decide whether he should go to Teterboro or should he go to Newark, which is another airport. And then he finally decided that the fault tolerance system had only 4 minutes or so. So going to New Jersey or to New York, Newark or Teterboro is not the ideal option. So it was more intuition than analysis at that point of time, taking into consideration different factors, basically. But the most important thing is there was a fault tolerance in the system that allowed him some time to decide where to land. And finally, he landed in the Hudson River. That's a different thing, but all passengers were saved and all that. Think about fault tolerance from that standpoint, which is like when you design something and some component fails, immediately the rest of the application should not fail. The application should be able to move forward, highlighting that the component has failed actually, but trying to see if the user can actually come and still finish the use case or the expected behavior and not crash then and there just because that particular component failed. That is what fault tolerance is all about. Long answer, but hope that helps. A couple of more messages coming in. Just give me a second. Okay. Yeah, I explained fault tolerance. Share some URLs that where we can explore more about shift left and shift right. Sure, Tyagarajan and Balan, we will try and share some URLs with you. Please share your email in this chat and we will do that. Okay. Okay, all right. I don't think there are any other questions actually. Yeah, unless you all have anything, we are done for the day. Thank you so much for taking the time to attend this and hope it was useful, everyone. Thank you.
Thank you, everyone.
Thank you, Kirti. Thanks, everyone.